It's just it's an equation where position is given based on time. Okay. So we still work in the XY plane. So we still have an XY coordinate grid. So that's, most everything that you see with parametrics is boils down to what you already know. Okay. But if I have a point here, okay, we don't just put XY. It is a function based on time and a function based on time here. Make it different. So you have two different equations you're going to be working with. So that gives us our x and our y. So x equals what? Our function of time, f, and g is our y value as a function of time.
In the parentheses, does it say f?
F of t and g of t.
Yeah. Comma or multiply?
Comma. Yeah, this is just an xy coordinate. You're just getting that coordinate from time, functions of time, rather than just x and y function. We can change our time functions to an xy function as well. It just doesn't provide us with as much information. One way that we write these is like, you can write them like this, like you probably saw in the multiple choice, I think, or you can write them like this. You can write that either way. You should recognize it as a parametric equation.
Why would you derive these questions? That's really information. So they're parent functions, so you
you don't have to have a function to do the derivative.
But what would be the application?
It's very similar to, like, you have a particle traveling at some time. What's the slope of the particle's direction? We'll get into it.
Because wouldn't these be discontinuous a lot of times?
They won't. No. Or they won't. So again, we can have points. This might be times 1, and you might have another one at time 4. You know, just analyzing at what time is what is the coordinate. Let me show you what a parabola looks like. In this, so let's sketch. The best way to do these is just to do a table of values for time, x and y. And yes, we can have negative time. So it's kind of funky. We can have negative time, but there you go. Okay, so just pick a few time values and analyze them and see what you get. Okay. Should get and then put those on a graph. So there's your curve. Here's the thing about parametrics, is that they're directional. Okay, so we indicate direction because time progresses in a directional manner, correct?
Yes.
So we had to indicate what direction that time is progressing on that graph. So we would, in this case, it's left to right. So don't forget your direction indicators. So you can see that parametrics can be handy because they indicate time, but they also indicate a direction of travel. Okay. So
Since we have direction indicators, should we still put the arrows at the end of the thing? At the endpoints?
yeah, we'll still do that because it goes,
Yeah.
the graph will still be infinite. Okay, so you can also write that as an XY function. Yeah. Okay. So let's write it as
Yes, great.
so set solve for t. Yeah, so solve the x value for t. Then what?
Separate them. Plug it into another data.
Plug it into what?
Why?
Yeah, the y one. Plug into y. So if y is 3 plus t squared, we have t. Just plug that in, and we get y equals 3 plus
Oh, this is
x
easier.
minus 4 over 2 squared.
Gnarly.
Well, it's pretty simple math, though. Yeah.
It's algebra problem. All right, what do you do with that? Foil it.
Why? Oh, can you go ahead?
We should go see.
Quite this cute.
And there's your more familiar form of a parabola. Right?
I mean, derive it, or not derive it, boil it, just to have it in a more easy to manipulate form, something we can easily recognize.
Yeah, pretty much. Right, so that's what a parabola looks like, and that's what it's called eliminating the parameter. So if you want to write that down, it's not.
At least I'll just get the honeycomb.
Not really lingo that you absolutely have to know, but it is something that we run into once in a while. All right. Good. So you kind of understand what parametric is? right, let's do a belt trajectory
Yeah.
problem.
Are these FRQ related problems?
Oh, yeah. Darn is the wrong word to use because they're easy.
Prefer to have FRQs and stuff everywhere.
Okay, there's your belt trajectory.
that ADT?
Parametric form?
Is that ADT, I'm assuming?
ADT.
Okay. That's a thing. Yeah, like
Are you talking about in the,
and the thing, it's like the number 80, though. It's
oh,
acronym right now.
ADT, I thought you were saying the letters.
Yeah, I am, now.
It's a security company.
So X is ADT, right? And this is our Y value. So if I ask you for the height
Why?
at time 5,
Why 5?
yeah, all you have to do is use the Y value because that's the height function, right? So
Is T in there, or?
turns out to be 800-ish.
Huh? How did you do it?
77.5 meters.
Oh,
Okay. If you do the math.
you have ish, what gives you?
I just thought it was closer to 4, and then it was closer to 5, but it's 4.9, so it's definitely closer to 5.
Wait, so what are the meters? I'm sorry,
Yeah, time is in seconds. I didn't mention this. Distance in meters.
because I'm like working and switching between chemistry and method measurement and actually measurement I am familiar with.
We use time.
We're
Seconds. Okay, so now that's just a like pre-calc problem, right? Okay.
Yeah.
Here's a more calculus-y problem. What is the maximum height?
Hey, there it is.
What is it, what is that?
Y1 instead of equal to 0.
Maximization problem.
Derive
y is equal to 0 to your
Way
test.
different.
Yeah.
What were you
Right,
trying to
so
do?
you said equal to 0.
What's the derivative of the y?
200 minus, that's 4.9%.
So you should know.
9.8.
No, but does that mean you know it?
Okay, what do you do with that?
You start equal to
Equal
0.
zero.
Find critical compliance, you side analysis, oh wait, no, you
Yes.
candidate test because it's going to ask.
Max.
What do you do about it?
I think that's about 20.4 seconds.
About, give or take.
Well, it might be a hundredth off. So that's the time at which maximum height occurs, right?
Yeah, it was
So now plug that into X.
No.
Just a
Well, maybe. No, that'd be easier because you used to.
Plug it into the y, because the y is what gives you the maximum height. All right, so we need to plug that back into the y to actually get the value for maximum height, because that's what we're asked for.
But you can even there.
I think it's like 2,041 meters. Okay.
So just like shooting that straight up.
I'm pretty sure that's what this one is. If you don't shoot it straight up, it brings sine into play. Trigonometric angles and stuff.
a lot.
This is just vertical.
If it was just horizontal, would the height, the function for height would be the same? Then you'd be more focused on X.
What was horizontal?
Yeah, just the gun instead of being vertical and finding height, if it was horizontal. Would that be dealing with sine, or would that just be dealing with X?
You'd still have your Y values.
And it'd just be the same number, right? So,
Well, it would drop to the ground. Okay. So, a little bit of calculus right there, but not too bad. Right? Same thing you've always known. We've talked about parametrizing a parabola. And did you notice that you still have a squared in here? Okay. If we do a parametric equation of a line, you think they're going to be any squareds? No, there's not. So your x value
Lines straight.
yeah.
How do you parametric?
follows this form.
Okay.
R and then BS.
Whatever, so.
Or it's RDBS.
That's true.
Hey, like you're
This line goes through
I'm gonna remember like that.
the point AB, and the slope is S over R. Okay, so you have A and B as your position indicators, and we still have our slope based on parametrics. Okay.
That sounds like your card.
All right, so let's write
Yeah.
roughly.
Oh, yeah, okay, I can do that. Sounds gross, but not. It's just good to really idea about that.
This little pie or something.
M. M is slope, remember? Y equals mx plus b.
I'm just showing the very fundamentals of math of chapters.
Yep.
You never will simply learn the right thing.
That didn't look like such great.
This should be getting mappy.
Do you like motor movement in your Commodore or no?
Yeah, I can move.
That you can like use it? Oh, you're, what, the one that was decapitated.
Can? Yeah.
It hurts like heck, I bet, but like.
Hurts like a mother. They told me not to.
I was just
So
wondering.
it's moved a few times and it hurts.
I
So
was just
yes,
wondering
there
if
is,
the nerves connected again, where you actually have motor control over it.
everything works.
That's
Cool.
wild.
Yeah.
It's crazy how.
So is
It's gonna take a while before I get really fine motor control again,
Oh, I bet.
and fine feeling too, like I can barely feel that. Feels like a stump.
How did you do it?
You decapitate
saw.
your thumb.
I'll tell you after we're done if you want. Okay.
so if the slope equals 4, S and R can literally be anything.
Yeah, you can choose, right? So if the slope is 4,
You have 8 over 2 or 16 over 4.
choose, so now, pay attention to that, it's plural,
You can challenge.
4/1.
right? So we can choose 4 over 1, right? So what would our equation be?
X equals 3 plus 4t.
No, it's supposed to be G.
Let's do
1t, and y equals
D plus 40.
81 plus 14. Okay. So that's one possible equation. What's another?
Oh,
Use 2, keep it simple.
2T 8T.
Yeah. I mean, you can go on, do whatever you want there. But there are an infinite number of parametric equations for a line.
That's weird. How do you know which one to use? Just what there doesn't matter. It's the simplest.
The easy one.
Yeah, just use the easiest one possible.
Keep it simple, say.
Well, that's all for today. Tomorrow we'll look at circles and ellipses and a little bit, and then we'll start to put some heavier calculus into this slope of a tangent line. We'll look at cycloids, et cetera, et cetera. We don't have to do area under these curves thing, but it's
Even then, that would be.
arc length and speed and slope. So, but that should be very familiar.
Let's see.
What's the bonus content? Is it 81 bonus content?
Yeah.
Cool.
Yeah, why is this one so lame today?
Do Thursday. It's quite a big assignment, but it's not good for Thursday. I'll be gone again Friday for a checkup in Denver, so. Yeah, so tomorrow we'll finish 11-1 and do slope. Thursday we'll do arc length and speed, which are equations you're very familiar with already. You just need to adapt them. And then Friday. Do you guys have